All right, here we go. So we got the sum of the torque. We have the mass of the rod. That is where? Center. Okay. So we're going to go mg times the cosine of the angle. Or we could look at it as the sine of 90 minus the angle. Because that's really, like, if we're talking about the axis of rotation and then the axis where the force is going here due to gravity, this is the angle that we're talking about. If we do it as the torque is equal to F times R sine of theta, it would be this angle here. If we're thinking about it as a force being directed along a perpendicular axis, then we're going to take mg and we're going to multiply it by cosine of theta. The distance away that we are here is L over 2. So we've got that. Okay, which direction is that pulling it in? Clockwise? So we're counting it as a negative? Okay. And then also, is this one negative?
Yes.
Yeah, because same thing, yeah? Okay. Here we've got 2mg cosine of theta again. And then what are we multiplying it by here? Times L, because it's the whole distance, yeah? So this is 0. This is L over 2 away. This is L away. Right? So what do we got here? We've got negative mg cosine theta over 2 minus 4mg cosine theta. Oh, I got an L over here. L over 2. So total, like negative 5/2. Where'd I get? Oh, a 4 over 2. I have 2. I'm just writing it over 2 so that I can subtract the fraction.
Oh.
Okay. So I have 2 here. I have 1/2. So I get negative 5/2. mg cosine theta times L. Good? Okay, now, if we're talking about I total, again, I said 1/3 ml squared. This is I for a rod about the endpoint. Okay. Plus, I have I for the block. I for the block is going to be 2m times the distance squared. So 2m L squared. So I have 2 plus 1/3. 7/3 m L squared. Mr. Toby, why? Did you do cosine theta here and you didn't do cosine theta here? Okay, when we're talking about rotational inertia, we're talking about just the mass, right, times the angle here. We're not talking about the force. That's the difference here. Okay, in this part, we're dealing with the force. We're breaking the force down into its components. Here, we're just straight up mass times the distance away. Okay, so that means if we're doing our angular acceleration is this negative 5/2 mg cosine theta L over 7/3 m L squared. M's cancel. 1 L cancels. We've got negative 5/2 times 3/7. On top, we have g cosine theta. On the bottom, we have just L. So we're ending up with 15 over 14. We got 15 g cosine theta. On the bottom, we got 14L. This is our angular acceleration, and we did it. We got it in within the